Okay, so I want to start today by throwing a term at you. And I guarantee, unless you're, I don't know, a very specific type of doctor or maybe a lawyer who's deep in industrial lawsuits, you have never heard this before.
Uh-huh.
And honestly, it sounds, well, it sounds underwhelming.
Oh, yeah. What's the term?
B-reader.
Ah, yes, it does sound a bit second rate, doesn't it?
Right. I mean, if I told you I was a B reader, you'd assume I was the understudy, the backup plan, the person who reads the script when the A reader is out sick.
Or maybe someone who only reads like B-list celebrity autobiographies.
Exactly. It just implies lesser than. But what if I told you that being a B reader is actually one of the most elite, exclusive, and high-pressure designations in the entire American medical system?
That is a much, much more accurate way to put it. It's a tiny club of people with a very, very specific skill set.
And what if I said these people hold a power that is, frankly, kind of terrifying? Imagine a job where you're sitting in a dark room staring at this blurry black and white image of a lung, and your opinion, your, subjective take on a shadow, can decide the fate of massive lawsuits, millions of dollars, and the medical truth for thousands of workers.
It's the ultimate high-stakes game. And the B definitely does not stand for backup.
So today on the Deep Dive, we are unpacking the very strange world of the bee reader. We're going to look at this intersection of medicine, human error, and the law. We've got NIOSH protocols, some pretty dense medical journals, and a few legal studies that I think are really going to make your jaw drop.
And it's a perfect topic because it really challenges something we all just assume, that medicine is subjective. We think an X-ray is a picture of the truth. But as we're about to find out, an X-ray is just a shadow. And shadows can change depending on who's looking.
Okay, so let's start at ground zero. What technically is a bee reader?
Okay, so a bee reader is a physician. They're usually already a specialist, like a radiologist or a pulmonologist. But they've gone a step further and gotten certified by NIOSH. That's the National Institute for Occupational Safety and Health. And their whole job, their specific certification, is to classify chest x-rays for signs of pneumoconiosis.
Pneumoconiosis, that's the big umbrella term for like dust diseases. Right?
That's it, yeah. It comes from the Greek. Pneumo for lung, conus for dust. So you're talking about things like asbestosis, silicosis, and the one that really kicked this whole thing off, coal workers' pneumoconiosis, black lung.
So these are the doctors who look at a lung x-ray and say, yep, there's dust damage here, or nope, these lungs are clear.
Well, see, that's where you have to be really careful with the wording. You said diagnose, which implies you're treating a patient. A B reader isn't necessarily diagnosing someone in that clinical sense. They are classifying an image.
That feels like a subtle distinction. What's the real difference there?
A clinical diagnosis is holistic. A doctor looks at you, listens to your breathing, asks about your history. A B reader is doing something much colder. It's epidemiological classification. They are looking at an image and mapping it against a really rigid international standard to generate a data point.
So they're turning a picture into a spreadsheet entry.
Precisely. And to do that, they use a system called the ILO classification. That's from the International Labor Office. And this is where the science part gets really, really intense.
I was looking at the notes on this ILO system, and it is just wildly complex. It's not just, is there dust, yes or no?
Not at all. It's a whole language. When dust gets in the lungs, the tissue reacts by forming these little scars, fibrosis. On an X-ray, they look like small white spots or opacities. The ILO system makes the doctor describe those spots with incredible precision. First, the shape and size.
And they use letters for this, right? Like P, Q, R, R.
They do. So if the spots are round, you have to measure them. Are they type P? That's up to 1.5 millimeters. Are they type Q? That's 1.5 to 3 millimeters.
Yeah.
Or are they type R 3 to 10?
So you're distinguishing between a dot the size of a pinhead and one the size of a lentil on a blurry film.
Exactly. And that's just for the round ones. If the scars are irregular, like little lines or squiggles, you have to classify them as type S, T, or U based on their width.
And then you judge how many there are.
Sort of. You judge the profusion, the density, how crowded are these spots. And this is the part that just blows my mind. They don't just use a simple 1, 2, 3 scale. They use a 12-point scale that actually incorporates uncertainty.
I saw this in the notes, like 1/0 or 1/2. Explain that, because it seems so weird.
It's not a fraction. It's like a mental toggle. So let's say I look at an X-ray. I think it's a category 1 definite but light scarring. But I hesitated for a second. I briefly thought, maybe this is a category 0, which is normal, so I code it as 10.
So the code literally says, I landed on 1, but I thought about 0.
That's it.
Yeah.
Or 21 means I decided it's a 2, but I considered calling it a 1. The system is built to capture the doctor's own internal debate. It acknowledges that the line between healthy and sick is, fuzzy.
That is incredibly nuanced. It's like they're trying to build a mathematical model for human hesitation.
They are, and that is why you need a special certification. You can't just grab any doctor and ask them to distinguish a type Q opacity from a type R while deciding between 11 and a 12.
Okay, so why did this whole system get created? Why couldn't regular radiologists just handle it?
Because of the absolute chaos of the 1970s, you have to go back to the origin story here. 1974.
The era of bell bottoms, the energy crisis,
Ah,
and a massive focus on coal miners.
right. The federal government had this huge surveillance program for coal miners. They were taking thousands of chest x-rays to track black lung, but when the data came back, they found a huge problem.
Which was?
Reader variability.
Which is just a polite scientific way of saying that doctors couldn't agree on anything.
It was a mess. I mean, you'd send a miner's x-ray to a doctor in Kentucky, and he'd say, "This man has stage 2 fibrosis. Get him out of the mine." You send the exact same film to a doctor in West Virginia, and he says, "Totally clear. Send him back to work."
That is a nightmare. For the miner, I mean.
Yeah.
Your whole life, your health, your compensation, your job, it all depends on which doctor happens to pick up your file.
It was scientifically unacceptable, and legally it was a disaster. It just proved that truth in these images was totally subjective. So NIOSH stepped in. They said, we need to calibrate the human eye, and they launched the B-Reader program.
And just to close the loop on the name, I saw a note that the B probably stands for the Black Lung Program.
That's the prevailing theory, yeah. The black lung connection. But honestly, given how hard the exam is, the B might as well stand for brutal.
Let's talk about that exam, because
Yeah.
this isn't some weekend seminar with free bagels.
Oh, not at all. Becoming a B reader is famously difficult. Just to give you a sense of the scale, as of October 2017, how many certified B readers do you think there were in the entire U.S.?
I don't know, there are thousands of radiologists, maybe 1,000,
181.
181. That's it. For the whole country.
That's it. Plus about 58 international ones. It is a microscopic club.
Why so few? Does nobody want to do it?
Oh, people want to do it. It can be very lucrative. But the exam is a massive filter. It takes place at one specific lab at NIOSH, the Appalachian Laboratory for Occupational Safety and Health, in Morgantown, West Virginia.
Even the location sounds intense.
Right.
Right in the heart of coal country.
It is. And the test involves a timed classification of 125 different radiographs. You have to sit there under the clock and correctly classify 125 x-rays using that super strict ILO standard. You have to get the P's and Q's right. You have to nail the perfusion.
And you're graded against a master key, right? A consensus from a panel of experts.
Yes, and if you deviate too much, you fail. The pass rates are historically low. But here is the real kicker. It's not like a degree where once you have it for life.
It expires.
Every 4 years. If you don't pass the recertification exam, you lose your status. You're out of the club.
That's incredible pressure. It's like having to retake your final exams every 4 years for your entire career.
It's to make sure their skills don't drift. Because remember, the original point was for research and compensation data.
Yeah.
They needed the human eye to act like a machine.
So we have this elite, super trained, constantly tested group of 181 experts. Theoretically, this should solve the variability problem. We should have perfect objectivity.
Theoretically. But this is where the story shifts from, a medical science story to more of a legal thriller, because the context started to change.
We moved beyond just monitoring coal miners.
Right. B readers became critical for all the dust diseases, asbestos, silica, and suddenly we weren't just talking about government surveillance, we were talking about toxic torts, massive lawsuits.
And where there's litigation, there's money.
Huge money, billions. And where there is money, there is pressure.
So let's unpack variability again. We talked about random variation,
Yeah.
just doctors disagreeing. But the sources highlight a different kind. Systematic variation.
Which is a polite way of saying bias.
Well, is it corruption?
Well, let's stick with the science of bias for a second. It can be cognitive. It happens when a reader has outside information that primes their brain. So if I hand you an x-ray and I say, this is Mr. Smith, he's 65, and he worked in an asbestos factory for 30 years, what is your brain going to do?
My brain is going to go hunting. I'm going to expect to see damage. I'll squint at every shadow until it looks like a problem.
Exactly. You lower your threshold for calling something positive. It might not even be conscious. You're just primed to see the pattern.
But then you add the money. If I'm a lawyer for Mr. Smith, I need a positive read to win my case. If you, the doctor, give me a negative read, well, I don't pay you for your testimony. I just go find another doctor.
And that creates a marketplace for positive readings. And this leads us to the most explosive piece of evidence we found, the Gitlin study.
I read this 3 times. I had to make sure I wasn't misinterpreting the numbers. This study basically took a flamethrower to the whole idea of B-reader objectivity. So walk us through the setup.
Okay. So they had a set of 492 chest x-rays. Group A was B readers who were retained by lawyers in asbestos litigation. These were the, hired guns for the plaintiffs.
Okay.
Group B was an independent panel of B readers who were blinded. So they didn't know who the patients were, no history, and they weren't being paid by a lawyer to find a specific result.
So Group A, the plaintiff's experts, versus Group B, the neutral scientists, same films. What happened?
The B readers hired by the lawyers found abnormalities, signs of disease in 95.9% of the cases.
96%. Okay, so basically almost everybody's sick.
Almost everyone. Now, the independent blinded panel, looking at the exact same images, they found abnormalities in only 4.5% of the cases.
Wait, stop. Let that sink in. 96% versus 4.5%.
And it's the gap.
That is not a gap. That's a canyon. I mean, if it was 60%, it's 50%, I'd say, okay, subjective. But 96 to 4. That means one group is seeing a plague, and the other group is seeing a room full of healthy lungs.
It highlights the massive, massive impact of context and financial incentive. The study suggests that when you are hired to find something, you find it. And remember, these aren't just random doctors. These are all NIOSH certified B readers, the Elite 181.
This is just, the implications are huge. If a lawyer can hire a B reader who will say positive 96% of the time, that's almost a guaranteed ticket to a settlement, isn't it? The certification itself was being weaponized.
That's exactly the argument that started to be made, that the B-reader stamp of approval had become a commodity. Lawyers weren't hiring the most accurate doctors, they were hiring the most positive doctors.
But just to play devil's advocate for a second, is it possible the independent panel was wrong? Maybe they were being too conservative.
It's possible. Radiology is subjective, but a 90-point spread. That suggests something systemic is going on. It suggests that objectivity dissolves when you know which side you're playing for.
So surely NIOSH didn't just let this go. Their entire mission is accuracy. If their gold standard certification is being used to game the legal system, that's a really bad look.
It was a crisis of credibility, absolutely. And this brings us to the cleanup phase. NIOSH responded by establishing a formal code of ethics for all B readers.
We have the code here. It's 10 points. And honestly, reading through them, some of these feel like things you shouldn't have to write down for a doctor.
Usually if a rule exists, it's because someone somewhere did the opposite.
Right. Okay, look at Rule 8. B readers shall not accept compensation that is contingent upon the findings of their chest radiograph classifications.
That's the bounty hunter rule. It tackles that problem head on. You can't have a fee that says, I get $500 for a negative read or $5,000 if I find disease. That is explicitly forbidden. You get paid for your time, not for the result.
That seems like Ethics 101.
It is, but you can imagine how creative the incentives could get. This shuts that down.
Then there's Rule 3. B readers shall not make clinical diagnoses based on chest radiograph classification alone.
And this circles back to what we said at the very beginning. A B reading is a classification. It's a data point. It is not a diagnosis. A doctor can't use this form to tell a patient, you have asbestosis. You need more evidence than that.
But then look at Rule 4. This one feels like the moral safety net. It says if a B reader sees something clinically important, they have to make sure the individual gets notified.
Right. Because imagine you're a B reader hired by a company. You're blinded. You get an x-ray and you see a massive tumor. But your only job is to look for dust. Technically, you could just check the no dust box and move on.
And the patient could die a year later because nobody told them.
Exactly. Rule 4 says you have a duty to the human being, not just to the form. You have to make sure someone alerts the patient. You can't just hide behind the process.
And the sources also mention a big push for blinding as a recommended practice.
It's the ultimate fix. The Gitlin study proved it works. If you want the truth, you have to hide the context. If the reader doesn't know who the patient is, who the lawyer is, or the job history, that bias just evaporates. The 96% drops down to 4%.
It's so ironic, isn't it? We usually think that to make a good decision, you need more information. But here, to get to the truth, the doctor actually needs less information.
That is the whole paradox of the B reader. Context creates a narrative, and narrative creates bias. To get to the raw data, the truth of the photons on the film, you have to strip the story away.
So where does this leave us today? Is the program still running?
It is. It's still the gold standard for tracking occupational lung disease. The exam in Morgantown is still brutal, and the certification is still incredibly rare.
But are they still fighting this variability battle?
I think variability will always be a factor as long as humans are doing the reading. The whole B-Reader program is an attempt to standardize human perception. It's an attempt to turn a subjective opinion, that shadow looks weird, into objective data.
And maybe that's the real takeaway here. We think of medical tests as binary, positive or negative. You have it or you don't.
But an X-ray is just a shadow on a plate. It requires interpretation, and interpretation requires a human brain. And brains are messy, pattern-seeking, bias-prone things.
It really makes you think. We spent this whole time on chest x-rays. But if these trained experts, the elite 181, can disagree 96% versus 4% of the time, depending on who's signing the check,
Right.
where else in medicine is objectivity just an illusion? What's happening with MRI interpretations for back surgery? Or pathology slides for cancer?
That's the really uncomfortable question, isn't it? The B-reader controversy just made it visible because we had the data from that one study. It makes you wonder what's happening in all the areas where we haven't done the study yet.
On that slightly terrifying note, I think we'll wrap up this deep dive.
Always a pleasure to undermine your faith in absolute truth.
Next time you see a medical report, remember the B-reader. Remember the P's and Q's. And maybe think about getting a blinded second opinion. We will catch you on the next one.
Take care.